We will be going over several different examples to explain when to use a directed aggregation relationship within Cameo and SysML. So there are two main reasons to use aggregation. The first is logical hierarchy. So what we're seeing in this diagram is directed composition relationships for how to decompose the security camera. So a logical breakdown would be different from the original directed composition breakdown, and in the logical breakdown you would use directed aggregation. So an example would be this mechanical logical breakdown. So we have the same system of interest, the camera, but we've broken it down just by mechanical power subsystems. You use the same English terminology to explain the relationship, the has a terminology. So the mechanical power subsystem has a stepper motor module. So this is the same as the directed composition where you say the security camera has a mount assembly. So these relationships are explained using the same English terminology. It's just that the breakdown is logical instead of the original decomposition. When you look into the mechanical power subsystem, you'll see that each of the directed aggregation relationships create a reference property. While if you go back to the original one with the directed composition relationship, you'll see that they create part properties. So the icon for little p is for part property, the icon for R is for reference property. The directed composition relationship and the directed aggregation relationship handle a little bit differently in simulation, so we'll show that. This is the part properties, and you can see how they are automatically shown, and you can go down and see the value properties values of tilt angle immediately. For the directed aggregation relationship, if you push play on the mechanical power subsystem, these are not automatically shown. However, if you go to settings and show reference properties, you can then push play and see your reference properties. But notice that the power value property is not immediately shown to you. So the way to get that shown is you would right click the power supply and then just add value. And now it will show you that 12 as our 12 volt power supply. As you can see, these directed aggregation relationships, which create reference properties, can be used to cut across the tree structure of a composition hierarchy, which allows additional decomposition views besides the primary system whole part hierarchy. The other way that directed aggregation relationships are used, other than the logical hierarchy, are for stored items. We have three examples. The Gatorade dispenser, which we'll look at now. So the Gatorade dispenser is composed of the valve, the insulated tank, and the insulated lid. But it also contains Gatorade and ice. And we would say that we would use the directed aggregation or reference properties for the Gatorade and ice because they are contained within the Gatorade dispenser system. Another example is the hotel furniture, where you have the hotel, and the hotel has rooms. The hotel is composed of rooms, and the room has or contains furniture. A good reference point for when to use directed aggregation relationships is if you can flip the system of interest upside down, whatever falls out would be the directed aggregation. So if you flip the hotel upside down, the rooms would not fall out, but the furniture inside the rooms would fall out. If you were to go back to tank, if you were to flip the Gatorade dispenser, assuming the lid's off, upside down, the liquid and the ice would fall out, but everything else would remain. Our last example is the Yeti cooler, which may sound similar to the Gatorade dispenser, but we offered two different ways to decompose it. You can decompose it using the directed composition relationships and have this block called payload or storage container, which is just giving the modeler a place to put items such as soda, beer, and ice for this situation, or you can use the directed aggregation relationship and do it that way. Both of these decompositions are valid. You'll have to decide which one works better for your application. A quick note on the multiplicities on the whole end of the directed composition relationships. So this one is actually referring to how flexible the block is underneath it. It's saying that mount assembly, electronics assembly, and camera module are not as modular as pan gimbal, tilt gimbal, platform, and stepper motor, which don't have those adornments. And what that means is this pan gimbal can be reused for many different applications for many different assemblies, not just the mount assembly. While the mount assembly, electronics assembly, and camera module, these are subassemblies which at this level will only be assembled to help create the security camera, the system of interest.